In Section 1.5, we'll discuss the SI units and prefixes so that you can begin converting between units. To be successful, you'll need to be able to recognize and use SI base units, SI derived units, metric prefixes, and understand the relationships between them. Let's begin. Length, mass, time, electric current, temperature, amount of substance, and luminous intensity are fundamental quantities that can be combined to describe every other quantity. These units are defined by a particular physical measurement, such as the length of a path of light, and are collectively called base units or fundamental units. The meter, lowercase m, is the base SI unit of length, and the kilogram, kg, is the SI base unit of mass, where 1 kilogram is equal to about 2.2 pounds, as shown in the figure here, where each pile represents 1 kilogram of the substance. It's important to realize that mass of an object, or how much substance it contains, is very different from the weight of an object, or the measure of the force of gravity on a mass. Mass is consistent regardless of how much gravity you're experiencing, while weight will vary. In chemistry, we'll spend our time working primarily with length, mass, time, temperature, and amount of substance. Although General Chemistry 2 will introduce you to some electrochemistry and discuss amps. The SI prefixes can be added to the base units to describe very large or very small measurements. The prefix kilo, K, multiplies the unit by 10 to the third, or 1,000. The prefix centi, C, multiplies the unit by 10 to the negative second, or 1 over 100th. Chemists used kilo, milli, micro, and nano more than any other metric prefixes, but you need to get used to converting between all of them. Let me show you an example. Which is the larger unit, 1 milligram or 1 megagram? Think back to the last prescription or over-the-counter medication you took. Was the dosage in milligrams or megagrams? You need to be able to zero in on what the difference is between using a capital M prefix and a lowercase m prefix. To tell which is larger, it's helpful to convert both quantities to a common unit of mass, such as grams, then compare the sizes. We see that 1 milligram equals 0.001 grams, while 1 megagram equals 1 with 6 zeros behind it, or 1 million grams. For that reason, 1 megagram is much larger than 1 milligram. Science also relies on derived units. You've already used derived units anytime you've measured the length, width, and height of an object to calculate the area or volume of that object. For example, centimeters squared is considered a derived unit representing area. Calculating the volume of a cube results in a cubic unit, which is another derived unit. Not all derived units are as straightforward as volume or speed, but we'll introduce them one at a time when working with them. We also need to keep some English to SI unit conversions handy. The ones I find most useful to memorize are the centimeter to inch conversion, the kilogram to pound conversion, and the liter to quart conversion. With those three memorized, you can use dimensional analysis to get any other needed units, provided you can recall all the tricky English conversions. Let's look at some examples. Determine which of the following values are given in SI base units, SI derived units, or English units. 1.5 gallons, 2.04 kilograms meters per second squared, 298 Kelvin, 8.25 reciprocal seconds. You'll get plenty of practice on the SI unit to English conversions in Section 1.7, so I'm holding additional examples until we cover that material. Until then, I'll leave you with the parting thoughts of the authors for this section.